Oh yeah, don't forget to start recording.
Oh yeah. It's oh, still opening.
I probably opened it 10 times thinking I was going to have a minute. I just
Uh,
ends up getting closed
and then
again.
somebody appeared with a question.
Yep.
Oh,
You know
what
it.
time you guys start every day? You guys start about this time or a little earlier?
We're here at 7.
7. Okay. So yeah, or a little bit earlier.
I was going to mention too, this Friday, I believe I have to do take my kids to a dentist appointment. So we might have to reschedule the training for Friday.
I'm down for rescheduling that one.
Okay.
That's fine.
Well, I'm looking at your screen, Robert. Or is that Marco's?
Yeah.
That's right.
No, this is mine.
Okay.
So
I was wondering what that is. I'm trying to close it. I'm like, what the heck? Tells you where my brain's at.
shall I just push it? I mean, I can work in the afternoon if you wanted to, or if you wanted to start a little later, or we can just reschedule. It doesn't really matter to me.
Yeah, probably be rescheduled. I gotta double check exactly when the appointment is, but I think it starts at 9. I probably won't
Okay.
get back to work till almost 11 or 12, and then by then we won't have enough time the rest of our day. So
Okay.
Fridays,
So I
Fridays are tough as it is because I don't remember anything come Monday usually.
So I'm just gonna take everything and just push it out one day, meaning our Wednesday, Friday schedule. I'll just shift everything down.
Sounds good.
Yeah, you know what I mean?
Yeah.
All right. All right. So Marco knows a little bit. For Barry here, we're gonna start all the way back at the beginning of sheet metal. Marco, did you play around with here kind of the 3 methods on how to create a sheet?
Didn't really do too much of that. I think I just kind of went with the base, number 1.
Okay, no problem. So we kind of have 3, we'll say 3 main ways to start sheet metal parts. I'm not saying there's only 3 ways, but there's 3 kind of basic ways. Number 1 is here, sheet metal. And here we have a base sheet. So base sheet, you click it, and these are for rectangular or square, of course, shapes. Um, in here you can give it your type of material, a length and a width. You can change the article number if you want here. And then you place it over here. I usually just stick it on the origin, and then you can apply or middle mouse. And here you see you get a feature step, or you can, always change the values as you want. You can change material and all that good stuff. So that's kind of number 1. Number 2 is using sketches, or you can draw really any type of shape, but you could, make it a little more, interesting if you wanted. And a shape like this, you say sheet metal from sketch. You pick some kind of material here. Okay, a Lucabond, sure, why not?
This might be a good place to import a DWG for this type of function from other people, other CAD operators.
For what
You know what I
purpose?
mean?
To try to create a
Well,
shape
if they,
that you already have?
yeah, yeah, if they've got something already worked out that they need to apply to what we're doing in iCAD, it'd just be a simple import.
We actually have a command 2D to a sketch that we can maybe not look at today, or maybe a little bit later, because I want to start
Okay.
simple here. But of course, you could do what you want here, but as you're adding that,
Mhm.
you gotta get your shortening parameters just right, so that, like, say the AutoCAD sketch shows probably the exterior of the lines, and you want to make sure everything's being shortened as it's folded, whether you're holding the exterior or if you want to hold the interior, and we'll get into all that here in a couple of minutes. But yeah, anything that you can make a sketch from, you can of course drive that type of shape.
Right.
The third main way is also from a sketch, but it's going basically into the in or out of the screen. So let's say you have something like that. You say a long sketch, and it's going to take care. You pick your material just like you would before. I don't know. Just pick something here. Let me zoom in a little bit. So here's where you can say standard benzone. You could mill it out like that if you want here. Let's say we just choose benzone since we have aluminum here, and then here you can say Z plus coming at us, Z minus going into the page, or we could do a double-sided where it takes half of the it says width here. Okay, it really means the distance, in or out of this,
Mhm.
towards or away from the sketch.
Bidirectional.
Yeah.
Yeah.
Those are the three ways. Maybe go ahead and try that quickly, if you weren't.
Is there a page this one's on? Which one was that?
Oh yeah, you can look at page 155.
I don't even have the document open.
Oh, do you know which document it is? It's the same one
Yeah,
we've been looking at.
introduction.
Yep.
What'd you say? 151? No.
155.
Yeah.
Oh, sketch. I gotta try. Oh, sketch. Ooh.
And radius. Radius.
All right, Robert.
Good?
No.
No.
Yeah. I really need 3 monitors. Man. Hard to
I
watch
hear
you
you.
guys in the PDF and
I hear you there. That's what I do.
yeah. So I'm going to share my screen.
Yes, please.
I'm going to delete this.
How to delete it?
Yeah. Oops.
Right click on the part. Say delete.
So it was here.
Yep.
Did it drop this down?
Yeah, you can
And
place it
then
somewhere, but now you gotta fill out the dialogue. So you got a place. You got some kind of dimensions, maybe not what you intended, but and you also can pick a material. You see
I noticed you
semi-finished
have that.
product. Check
That's
that.
checked in there. You do need that checked?
Yeah, if you check that, now you're grabbing a library material, whereas if you uncheck it, you're just assigning a thickness with no material. Maybe to assign the material later, or maybe it just doesn't matter so much if it's just for some kind of visual.
So it doesn't have to be checked?
It doesn't have to be, but generally
Okay.
speaking, why would you not be picking a material?
Maybe we didn't decide on one yet. Well, we could
You
just
know,
go
you
with a material.
can always change it later.
Right. Just go with that.
Okay.
And then we got that. And then we can do something different here. Just
Yeah.
go
Sign some kind of width and length.
something. And that looks all right. And then step 2 was
Create a sketch.
from sketch. Just hit the from sketch button.
You can do it from right here. You see the little red lines at the very top right. You can create your sketch before calling the command, or you can call the command and then create your sketch. It kind of doesn't really matter so much. But do you see the button I'm talking about? You got select sketch, and you got the little eyeball, and then you got edit
This one?
sketch, which is in the middle, and then the right it says new sketch.
Mm-hmm.
So you can say
This is
new
what we want.
sketch. Yeah, because we want to create
Right.
one. stick a plane somewhere.
How about right there?
Okay.
And so now it's just a matter of,
Yeah, just
That's
draft
fine.
some kind of shape.
a sketch. I'm seeing this up here.
Well, yeah, that's when you're done drafting, you then click
It's
apply
after.
sketch, but you gotta draft something.
Right? Let's go. Let me do something like this.
Okay. Middle mouse. There you go.
And then, you know, I'm going to minimize you. Sorry, nothing personal. I'm going to put you off the other side of the screen. I can see this PDF.
Okay.
Sorry about that.
That's no problem.
I know. All right. That's better. Okay. And number 3 would be,
Well, go ahead and apply, and then create the sheet. So there you go. Now it's the same story. You can pick a material or not, and then give it a thickness. Well, if you pick the material, it will automatically apply the thickness. If you don't, then you'll need to type a thickness in because it's got to know how much to go in the plus or minus Z.
right? Okay, so can we tweak into Z? Can we just, what was the other one? 0.5? 0.05?
So, okay, so you have semi-finished product checked. So that's that's it's expecting for you to pick a material. You uncheck there. Now you can just type an arbitrary thickness of the part.
Like that.
Okay.
Okay.
And just okay. And you got your second part there.
On number 2.
Number 2 or number 3?
Number 3.
So number 3 was, remember, you're going to do a sketch, but you're going to anticipate that the material is going to go plus or minus Z, a certain width, like in or out of the screen. Well, depending on how you have it oriented. So let's start with a sketch, or you could do what you did a minute ago and call it the command first. It's your choice.
Windows sketch, I guess,
Okay.
because that's what's in the
And
book.
when you zoom out a little bit, I'm
Yeah.
curious as to why we don't see your screen planes. Okay, there you are. There they are. So,
All right.
you might pick something on the XY world plane so that we can go in or out of the.
You just select the plane here, or on this one.
You can pick any one you want. I picked the XZ plane just
X and
because
Z.
I like the orientation.
Okay. And then
Now you
what?
draft something, but remember, you're just working with lines. This is not an enclosed shape. This is just a linear shape.
Okay. We're not enclosing anything.
No, look on the page 155.
Yeah.
You see how at the bottom, you see what we're trying to make? You're gonna draft some form of linear shape. It can have segments and angles and whatever, but it's gonna follow your linear shape in the plus or minus z as you specify.
Now I need a line. All right, where am I at here? There's the
You
plane.
got a sketch going. Yep. Now you can start.
Yep.
You know, a line perhaps.
I got a line. We'll go with that.
Okay.
And then we're looking at
Remember 20 ways. So it's going to be, of course, in sheet metal, and it's going to be the one that says sheet along sketch.
where am I looking?
Sheet metal.
Oh. Let's be this.
That one. Yep, that's correct.
And
All right. Pretty
Okay,
similar
so
here.
this-
You can do material or just define a thickness.
we'll go picture 5. And then zone, we do more milling. We try milling edge zone. And this is go left or right. There's a bend radius. We don't need it. Does this apply? What if we go 0? Can we go, or will there always be a bend radius?
I mean, there always is. It might let you assign one of 0. I can't remember there, but when you have a bend zone, there's always going to be a radius, right?
Yep.
I'm not seeing a preview. I don't know if it's just the orientation of the screen. Can you rotate it just a little bit? I kind of see the preview. Okay, I guess it's just maybe the way you have the color of your screen.
Yeah, I should probably change that. I don't remember how I did it. Okay, so just hit OK.
Yeah, let's try it. I want to see what happens. There you go. Okay, so I've never seen a preview like that.
Breaking new ground.
The only interesting thing here is that the milling edge zones are on the front
I see that.
instead of typically the back. So if that was to happen, you didn't want, you just double click the feature step like we've been
Which
doing.
is, that would be, where would the feature, it would be up here, right?
That's a view. So that's the view. At the bottom, you have just your structure, but your feature step is the one to the right.
I'm confused. Oh, up here. All right,
Yeah,
gotcha.
feature. And then you can double click the step that you see there, sheet along sketch.
And we need to
So
put
you
that
can say
milling edge
milled
zone.
side. You can switch it from
Mhm.
left to right, for example.
That looks better.
Yep.
But now it's, okay, that looks better. Okay,
Makes sense? Kind of?
yeah, yep, it does. Not quite how we would mill it, but I get the
How would you
point.
mill
we would have it to where, there would be not such a huge void here. Marco's got this stuff dialed
Well, you
in,
can define that. So,
right?
yeah,
So,
we'll get to it a little bit later, but basically there's a tool, a tool library in a way, where you can define the geometry of the cutting area or the cutout.
right.
So you can take the tools that you would use for any of the routing purposes that you might want to like that you would use for a modeled function. So if you model um, acute angles, or you got 90 60s, whatever, you got the different toolings that you're going to use based on the situation, so you can um, get the geometries of those of the tools with the cutting area that they'll produce, and you can put it into a section in the catalog, and then your milling edge grooves here will be modeled, assuming the dimensions of the tooling that you put in the library. So that's kind of how it works.
Okay.
All right. So let's start this hat looking thing, sort of. I guess it's from a sideways view, it looks like an upside down hat. I don't know. I know I wrote this book, but I took an existing exercise from somebody else, and I just sort of put my spin on it. But hat profile, I didn't really have any other better ideas, so I went with that. So I'm gonna come to a new drawing. So let's use one of these strategies that we just learned. For example, the first one, create base sheet.
So do we save this drawing or no?
You can if you want.
Sure.
I'm not going to ask you for it.
Okay. Thank you.
All right. So here we're going to use, well, you use whatever material you want. Here the book uses a 12 gauge aluminum 8x3 sheet. A little small, but okay. So here's Barry, where you could select the material. So use the semi-finished product. And pick whatever you like. I'm going to use this one. I'll leave this open for a minute.
Yeah. Where would you find 12 gauge? I'm looking for it. I see it.
ISD US Camp Black, which means sheet metal. I'm sure you knew that.
Actually, it says in mine, it says US sheet. Oh, but we're not doing the liquid one.
Yeah, mine does
Mine
too.
says-
Well, US sheet here,
Yeah.
Yep.
and then here
Yeah, ISD US sheet.
we have
Of what?
ISD US Camp Black, which has some of the gauges in here.
Mhm.
I can of course go into the catalog and change change the name here to like an alias, and I could fix that. I just haven't.
We're good.
Yeah, but whatever you want to
Fine,
use.
but
And,
yeah.
and
All right. So
okay or apply or middle mouse. And now
all
we're
right.
going to do a flange.
To attach.
That's not attached. Yeah. So the way flanges work in HiCAD is, of course, you're going to select the edge that it applies to. But here's the rule. If you select the top edge, the flange, hold on, I'm sorry. Let's say shorten outer. The flange goes down. If you
Okay.
pick the bottom edge, you see here I'm switching to the bottom edge, the flange goes up. So it does the opposite kind of, you pick the bottom for it to go up or pick the top for it to go bottom. I never worked sheet metal in any other software, so I have no idea how Inventor or SolidWorks does that, but this is how we do it.
Okay. So select an edge. First off, how do we get there? I was right there with you. So you're just doing attach, select an edge. We'll go down. And that's it. We can tweak it here with types of bend angles or no.
Yeah, so here are the options. Let's kind of start at the top. Here's where you could say, for example, you want it to go from this point to, this point instead. So if you wanted a unique, here when you uncheck this, then it goes back to the whole length of the edge that you're applying it to. Now here you got your length, and you have a lot of reference options. And if you look at this for a moment, I hope it makes sense. Basically, here's where you can say you want to hold the bottom of the sheet to the top edge or corner of the end of the flange. Say for example, I change it to inner. So you see it gets slightly longer. It was kind of quick, but so shorten inner, for example. You see how it holds from the inside of the flange to the dimension of the base sheet. So you got all these different options, and you can look at them. To be honest with you, for the cladding that you're doing, you're probably going to say outer distance. I think for most situations, you could also say direct outer here, a little higher. Which when you have a 90 degree flange, direct outer and outer gets you to the same place. If you
Okay.
had an angle, a unique angle, 45 or 60 or whatever, you see now that becomes a factor on how you want the dimensions of that flange length to be.
Okay.
I know there's a lot here, maybe a little overwhelming, but I think to tell you from working with other customers, this outer distance and direct outer are probably going to be what you use 90 to 95% of the time. I'm thinking,
Okay.
but there's always unique situations, and the options are here, and you can look at them, or we can look at them together if something special arises. So let's say outer distance, for example. And so here's the angle, of course. So obviously you change this to something else. 45. It's gonna.
Yeah.
So now down here, so this is the length of the flange, and these are the parameters for that. This,
Are those your gay friends? Are you on a call? Yeah, this is a meeting. Welcome to the meeting with my gay friends. That's okay. My boss is gay. And he said, "Awesome gay." I did. I'm gonna call you. It's okay for you to do that, not me. You say hi to your buddy. That's fine. My gay coworker says hi, guys.
oh, hey,
Sorry about that.
it's all right.
It's tough to be
Um,
me sometimes. I'm with you, Robert. I just changed the angle, and I've got 45. You've got 90.
I just moved it back. So the second fitting mode here. So this is the length of the flange. This is the fitting mode of basically the bend, or the how do you want the things to be measured here? Do you want to hold the do you want the exterior surface of that flange to hold with the base sheet, or do you want it, for example, go away here, like shorten inner? Now the inside
Okay.
surface of the sheet is going to
Okay.
hold to the opposite end of the base sheet.
The trick is the line with the arrows, I think,
Yeah.
because
So
it'll tell you right there.
yeah, I mean the images are actually really pretty good here.
Mhm.
To explain what's going on. Again, with your business, shorten outer. I know we haven't done the element cladding command yet, but these panels are driven by an exterior shape. So whatever that is, say, and you're going to want to hold that. As you add flanges, you don't want the panel getting wider, getting a little bit wider,
Right.
because of the fitting mode. You want it to shorten the outer so that everything conforms to the base sheet of that panel. That's going to be really important, because otherwise you're going to have, you want to hold your reveal that you're going to specify for that elevation. And if you're not using shorten outer, then things are going to start creeping out on you, and you're going to have problems.
Right.
So just in the back of your mind, 95% of the time, you're going to say shorten outer here and probably outer distance here, or direct outer if you have a special angle or something.
Okay. I've got short and outer.
And you got some fancy things here. You got to a certain plane. If you're trying to line a flange up to be parallel to another flange, then this can be nice. And I believe we'll use that here in a little bit.
So I have a question.
Yeah.
When we select like direct outer and shorten outer, do those become the new default next time we go to use this function, or do we have to reselect shorten outer and direct outer every time?
It probably
Um,
it remembers what you did last. So when you click OK or apply, this dialog is now, when you open it up again, it's going to look just like the last command that you used it in.
Okay.
And we don't have a little favorite box here in this menu. Um, maybe that would be good. Maybe they thought that since every part's generally unique with different lengths and angles, that you're going to have to pay attention to this anyway. So they didn't offer the little star. But I don't know if that would be really useful, then that's something that we could recommend to them. But thinking that they didn't do that for the reason that everything usually is a little unique based on the situation.
Now I see you've got an apply immediate right above your apply button. Is that like a real time changes? Bless you,
Yeah,
Marco.
I think what would happen there,
Yeah, we don't have that. I don't have that. Oh, wait a minute. Maybe I do.
it's
No, I
there, it's
don't.
just probably not checked.
I don't see, it doesn't say apply immediate for me.
Really?
Yep. I see my screen.
Yeah.
I wonder if that's, maybe they just wrote that out.
I was on there. You do it.
Select an edge. Select some kind of edge. That's crazy.
Woohoo.
What about you,
So it's a
Marco? Do you
D.
have that little apply immediately?
Oh, shit.
Yeah, I don't have to apply.
Immediate.
Yeah. Gotta back it up to. Flanges remove, attack flange. I don't apply immediate either. That's.
That's just another version you have to add, Robert.
Select an edge.
Along with your 20 other versions of this software.
But it's it's always been there. That's what
So I'm going to drop this down and see if it's there. It's not there either for the. I figured, well, maybe it's part of that cutout box, but it's not.
let's see. It's not in this menu either. What makes me so special?
Because you're Robert.
I have no idea.
Everything else looks good. Looks the
Yeah.
same, right?
I don't think it's an option. Huh? Huh? I'll keep an eye out on that. I'll stumble on it one day.
Yep.
All right. So we got a flange to one side. We're just gonna create the same one on the other side. Notice
Didn't share
that
your
here
screen.
it remembered exactly what I did, and you wouldn't have needed to close the command. So let's say that you haven't done a flange yet. And so here you can say
You
edge,
can't
middle
see your screen,
mouse.
Robert.
Huh?
Can't see your screen.
Oh.
There we go.
You can't telepathically use
My
magic
powers are a
to.
little bit off today.
Okay, fair enough. So what I was saying is that you don't have to end the command. So you can say here, oh, you see that? I have this button checked. It did apply immediately. Not quite what I
I'm
wanted.
guessing it's like it's a real time thing versus even though we're pretty much already, we don't have to do apply immediately because it applies immediately when we select a line. Or is
Well,
it always like that?
this hasn't applied yet. This is a preview. So
Okay.
nothing is actually built till you click
Okay.
apply or middle mouse or OK.
Okay.
All
right.
So the idea is that here you open this up, you say, you select your edge, you say middle mouse, you select your next edge, you say middle mouse, and you could come right away into these other ones, which are only 1 inch. Middle mouse, and do the same for the other side. And so you're not having to open and close the box and click the button up here every single time. You just keep it opened. You do, all the flanges that are on your mind at that particular moment. And then when you're done, you can exit the dialog.
Okay.
Now, I don't know if you noticed at the bottom here something called allowance method.
You broke up there.
Oh. At the bottom here, you may have noticed, but we have something called allowance method. What that means is what parameters or which rules are active to determine the
Oh,
length correction
Yeah.
for this bend.
Gotcha.
And we have, if I uncheck this here, I can pick either without. You can configure your own strategies based on either presumed data or real data or just good practice. We have some defaults in here, and I've got a few extras in here, so I'm trying to remember what you have. I know you got ACP and ACP outside. maybe an aluminum one. Do you probably have about half of what I have here? If you uncheck the box.
Yeah.
Yeah, we've got the DIN 6935, all the ACPs, chamfer, Aurora, Emerald, Helmich, and Kaiser.
Okay. So what does this mean? So in your HiCAD exe folder, we've got a few little supplementary applications in here. You see some executables in here. You're probably not going to use too many of them, but we have one called ABW editor. And then while you're probably thinking, what the heck is ABW? ABW format is what we call what we call the files that control these allowance methods. It has something to do with German, I'm sure.
Yeah.
An ABW editor, when I open this, I now have an editor for all the allowance methods on your system. So, and here's where, I could say, aluminum. Basically, what's happening here is we have different allowance method strategies. So let's look at those for a minute. In the training material under channel, so we've been working under a book that covers a variety of topics, but we also have a sheet metal folder here.
Yeah.
And we have a
Female training English.
we have sheet metal training English. And this is a more lengthy sheet metal book, but the very similar concepts have been explained. For example, here you got base sheet. But all the way at the back, I'll tell you the page in a minute. We have possible allowance methods in HiCAD on page 136. So we have these different procedures here that are possible here. So here, this page describes procedure Z, which over here is an option that can be selected. So procedure Z, the calculation method according to procedure Z is based on the dimension of
Good morning. Okay. Okay, thank you. All right, bye. All right, sorry about that.
All right.
Oh,
All right. I thought that might have been another call, Barry. Is that somebody
It
else's
is.
phone? Oh,
She told me she's gonna call back, and she told me to ignore it.
oh, well, there you go.
Okay.
And then you're doing exactly what she asked.
Yep. I'm gonna reject it. Apparently, my extension, only a few people had my correct extension, which is really the way I liked it. She's ruining it for me.
Oh, man. Let's see here. Okay. So this one, so procedure Z is based on the dimension of the outside measurements of the product. The maximum dimension of the fold is measured via tangent to the outside radius, perpendicular to edge of the product. Outside dimension reduced with the correction summoned give the actual length of the development. So, and here we have a procedure H, which is a little bit different. Procedure I. And basically what this means is that for sheet thicknesses of all these in this table, so it looks like ½ inch up to 1 inch, 2 inch, 3 inch, 4 inch, with a bend angle of 5 in this situation, with an inner radius from 0 to this number. So basically, all inner radius is that are specified are going to have a correction of, well, in this case, 0. It's so small that I guess it's going to be ignored here. But let's look at one that actually has a factor. You know, here, a 90-degree. So a 90-degree flange for this thickness is going to have a factor here of 0.8, and that's millimeters. At the moment, this receives millimeters, so we would need to convert it, unfortunately.
Okay.
I don't know a way. I think that's the way it is here.
So so this is where we tweak that. I think they call it a curve. It's got a couple different names. But we can dial these into what our machines create,
Yes,
and then
you can dial this in. You can. I would say you take an existing table. So I would say you run some tests. You model
yeah,
some small parts. You explore the ones that are already in your system. You maybe find one that's really close, and then tweak it. I have a lot of customers that they stick with this DIN standard because they say it works almost perfectly. So I'll throw that out there. They don't even mess with what I'm showing you here, but I want you to know that it's there.
okay.
Because you might want to use it. But I don't think I know of anybody using it in this region. Region meaning North America, large region, but it's here. I wouldn't dwell on it too much right now. I would
They
continue
don't
learning the
use,
commands in general.
yeah. Are you
But
saying
know
they
that
don't
that's
use
there.
that standard, or they don't adjust like you showed us? They
Okay,
don't
so
use
this particular one is not adjustable. It is per the standard, and I don't know much about the standard, to be honest with you. A little bit is described here on page 134.
Okay.
Maybe it's because I was never a sheet metal guy. I was a mechanical engineer focused on other items, mainly power related, power systems and power generation systems. But
Okay.
I get the idea. So my suggestion would be start with that DIN, really. Run some
Yeah.
tests, see what you think about it. You can also try, of course, some of the other ones in there per these different methods. These ACPs will be for ACM that's not grooved, which makes me think, oh, when is that ever done? ACM is done automatically. So there is a correction factor that we automatically do, and everybody doesn't like that at first because they can't control it until they start cutting parts and say it comes out just perfect. So they did a pretty good job there. So again, ACM, make some parts or run some tests. Aluminum or other materials, make some parts or run some tests. See how it comes out.
And we could, this is where we create our new standard, right?
And if you want to create something unique, probably you would copy one of these existing ones and start making your tweaks, or you could just adopt one of these. You don't have to copy it, but I tend to say tuck a copy away. But if you mess up these defaults, if you mess up one of these defaults, guess what? It's on the DVD that we installed HiCAD from, and that could be, reproduced, or you could call me up and say, hey, I want your can you send me one, because guess what, they all live here in macro ABWs. So here they are, ABW files, if you sort by type. And here you go.
So those are, yeah, so what we would do, those are all just like small text files, I imagine. We would just,
Here it is.
we're not really hurting for drive space. How big is that folder? Could we just archive that, or make an archive of that folder, right? Back up that folder. Yeah.
This one, I don't particularly see this one being any kind of show-stopping amount.
Right.
8 meg.
Oh,
there
yeah.
you go.
Yeah. All right. I'll make a note to back that up. That way, if we do, we might. I think maybe that standard might work for us. Because, we got installers.
Pretty
They don't
close to
follow any
what you want.
standards.
Yeah.
Yeah.
And if there's a particular standard that works better for North America, I'm all ears. I just don't come from that business to necessarily know.
Yeah.
I'd like to hire somebody. We have too many mechanicals over here. We got Eddie. I don't know. You worked with Nicholas, right? Did you work with Nicholas or Eddie on sales?
A little bit. Yeah.
Nicholas.
So we have Eddie. Eddie used to be a counterpart to me, and he decided to move to sales. So he has some pretty good technical knowledge, so he can talk a little more about the product. Nicholas is doing well, but he's learning bit by bit. But I'd like to try to find somebody. Our other counterpart is a computer engineer, so he's real good writing the little macros and the APIs, and he's pretty good with the software in general. But the real world experience, he's right out of school, so he doesn't have that. And then my real world experience is mechanical engineering. I'd like to find somebody that actually comes from the cladding or metalworks or somebody to be on the team. So that'd be great to have at a certain moment.
Yeah.
But for now, you're stuck with me.
All right. No complaints. Yeah.
All right. So I wanted to explain that. So now we've got a little part. Where's it? Looking something like this. And here also on the allowance method, you can say here, let's see, change allowance method. Say you want to change the correction for either this sheet or all sheets or just a particular bend zone. Yes, you can come back into these features and change it one by one, but why would you want to do that? Here you could say change all sheets to a particular one here, and make a specific or global change here.
That's
So
really
that's
cool.
also pretty nice.
Yeah. Yeah.
All right. A development. That's what we call a flat pattern, or whatever you want to call it. So development button is here. Of course, we're in sheet metal, and we come over here to sheet development. And here we also got quite a bit of options going on. Here's where you can say, for example, you got automatic alignment, where you call up the command and it decides whether to orient it vertically or horizontally. And if you want to change your pick yourself, you can say via edge selection. And here's where if you say that edge, it'll orient this way, or this edge, it'll orient, well, kind of like what we saw a second ago. So automatic, and then here you can influence via the length of the edge that you pick. Here we have different type of, for example, dimensionings. Maybe you're going to export it into CAM, and you really don't need the dimensions shown because your CAM program's gonna connect with the outer, with any outer inner contours or bend lines. So here, here dimensions, bend lines. You see, it's taking it away based on what you specify here. Here we got representations. Let's say I take away bend lines. The bend lines are disappearing. I'm not sure why you'd want that,
So,
but
well, it would be for it would be for I was just thinking it would be for the people assembling the panels. But then again, they would just be looking at a 3D isolated drawing with call outs and angles and things like that. Right?
most likely. Well, it depends on what you want to create, what type of drawing, but usually you'll have some kind of maybe something like this, which you can export to DXF for your CAM. And then you have something that shows more information like this that you put on some kind of fabrication sheet. And then you may also have either on the same sheet or a different sheet, like an assembly print, usually with the parts called out in balloons or
Right.
annotations, whatever you want to call it. Maybe
With
a
the
little
hardware
materials
included.
table, a materials table there showing the parts that are needed, or whatever. We haven't done fab drawings yet. I don't know if you probably remember from the demos. It's probably something you found very interesting. The automatic, we'll call them fab tickets. So when we start setting that up for you, or we do it together or whatever, you know, we have a lot of control over that. What you want, what views you want to see, whether you want separate sheets, if you want if you want your sheet metal fab to be on one sheet and more of an assembly style print on another, that's okay. Some customers combine them, so you only have one piece of paper per panel. It kind of depends on what, you know, where you want to go there, either based on what you do now, or maybe you want to tweak a few things, or whatever.
Right.
So here, for example, look a little further here, you can say, you can call out these angles or not. Here we have, I hope, a similar looking screen here. Remember this, here's our same sort of template annotator here for bend angle field. Here you can make that, bigger if you want. Your text gets larger.
Yeah, I like the larger text. Yeah, I guess the other question is on your example that this is representing, you've got Ben, so these lines should, some of these lines should represent the side we're looking at. Some of these lines should represent the other side we're looking at.
Yeah. So
Based upon the model you have.
with
How
with
are,
the default, with the setting I have loaded right now, obviously they're all solid lines, as opposed to maybe some are solid and some are dashed, or whatever
different
you have in
colors?
mind there.
I was thinking, me just looking at this, I'd fold them all the same way. So
Yeah, you don't know.
what tells the user that, hey, we fold this on this side, we fold this one on the other side.
Well, looky here. You got all of this stuff that you can configure, which is probably slightly overwhelming. But here I could say I want, dashed lines for positive or negatives. And here we got, some of them are dashed and some are solid.
Yeah.
Again,
Yep,
you got a lot
exactly.
of control here.
Right.
This,
Where was that at?
oh,
Setting in mind.
yeah, here we got
Okay.
extended options, and here's where we got tons of stuff here,
Okay.
where you can force certain items to certain colors, line types, and layers. And the layers would play a role into the export. In HiCAD, you're not going to screw around with layers like you do AutoCAD to control things. You're going to control most items via the dialogues and the options that are already available, not via layer. But
Okay.
exporting a sheet metal development like this, your layer number and your export settings kind of need to jive together. So they need to communicate correctly so that the output gets the way you want. And we'll look at that. But here's where you can force, the edges here. I believe that's the outer contour. What color, what line type, what layer. You can pick, any number here. It doesn't really matter. It's just controlling things in your own ideas. So, for example, inner contour would be, say you got a cutout, say you got a circular cutout or some special for a pipe or something that's got to go through. Processing edges would be anything used with the 3D bore thread command. Where you got all those different, you got slot, you got a hole thread, bore, slot, counter bore, countersink. Remember that one screen that had all that different stuff?
I think you just passed it, didn't you? Oh,
Probably.
no, maybe not.
I was thinking it was closer to the front, but
I think there is one closer to the front.
in here,
Yep.
somewhere in here. Okay, maybe the menu is in here, but the button here, it's a little different now, but it's that bore button that had the
Right.
multi-function. Find my spot again.
Sorry. Yeah, I
okay.
remember the bore button.
So anything that's used with that bore is called a standard processing. Now, if you do a subtraction, it's now an inner contour. So there's that's the differentiating.
Okay.
Some people use that to control different things to different layers. Uh, say you want some slots to go to a certain layer, but holes to go to another. They might actually model their slots as a contour or a subtraction so that they can send that to a different layer. But kind of to each their own there. So here's the first page. Generally speaking, you're probably, these you might leave alone until you get to milling and folding. Now this is a little more interesting, but here we got some options here. To be honest, I don't play so much here. I don't play so much here, but here you got some shortening options. If you want to use punchings. Well, let's look at milling and folding here. Here's where, say you got ACM bends where you're grooving out on the router or whatever. Here's where, remember I was talking about that tool library? Here's where you can set all these different tools. And now let's look at this inside the catalog. I'm going to select it from here because I don't want to close out all the menus that I have. I'm looking for I. Obviously, I don't know how to spell here. So here in your catalog, we got groove somewhere in here.
You got a search function on that thing?
Yeah, that's usually what I use
Okay.
here because I never can remember where these grooves are. And here it's going to be this one right here, standard groove form. Standard groove form. I'm looking for G. It's really an S. That's usually why I can't ever find it. So here, if I double click, it takes me right in. And here, looky here, it was right here staring at me the whole time. I was looking for groove, not composite panels groove. But here's your table. So this is the data behind this menu. And here I can double click on one. So here is your, okay, maybe it doesn't need to be quite that big. Here's for example, a 90-degree groove with W, B, and D. And this is millimeters. Might be able to change it. Some of them you can, some of them you can't. Unit, well, that's an angle. Let's see. Here, it looks like it might let us change it. But we got W, B, and D. And these are the dimensions of this groove. So W is obviously the angle. B is going to be the width of the bottom of the groove in millimeters. Remember, and this is D, also in millimeters. And these are some standards that comes out of the box. But you can change these numbers to reflect the tooling that you actually use. Or you cut the groove. Sometimes it's hard to, how do you really measure this tool? I guess you could go off the manufacturer's specifications, but then as it wears a little bit, you know, do you want to adjust or no? So you could always cut the groove, and you could put the caliper edge down in there and try to catch that corner, and then you could come up with a number. But anyway, here's where you can specify that for These tools, you can add new items here, like, new record.
Oh,
You
cool.
can, so you're not limited here. These are just some examples that are already loaded into your system.
And then to get there, how did you get there? I see it says Kate editor, catalog editor.
Yeah, so this is the, have we ever looked at this before? Or is this the first time?
We may have.
Okay, no problem. I'm blurring you in my head with somebody else I'm working with. It's kind of hard when you got two classes going at about
Okay.
at the same time. But this
We're
is
all
the
blurry.
standard catalog editor, which you can. I'm going to back out of this. You can get that. Well, of course, there goes my development. You can access that
Sorry.
here.
Okay.
You
Kate
can access
editor.
that here, or you can go to your start menu, all programs, ISD, and then standard park catalog editor.
Okay. From the start menu.
We went into this a little bit when we were like saving your profile that we did in 2D contour, and then we saved it. But yeah, we haven't done too much here.
Okay. Did you say standard catalog editor or standard part editor from the start menu? I think it's catalog editor, right?
Standard
It's under
part
HiCAD anyway,
catalog.
right? Standard
You're
part
gonna
catalog.
catch me. You're gonna catch me fine just calling it catalog, or cat editor.
Okay. I got you.
Yeah, that's probably not helping. We got like different words used in different menus.
All right. I feel like I'm on vacation to Germany sometimes.
So like here we have catalog, but then
Right.
when you open this cat editor, it is exactly the same as saying start menu,
Mm-hmm.
standard part
Okay.
catalog editor.
Yeah.
So cat editor is catalog editor for short. And here it's actually called cat editor is the name of the this is a database, basically the database that manages all the library parts. And then here you got here somewhere groove form. All right, so here's where, of course, you can pick your tool. So this is where you would want to have the tools listed that you used in the part that you just made. So I know we used bend zones here. So let's say that we used groove zones instead. You would want to have those tools in this menu. Otherwise, it's going to default to the top here, and use some general settings. So it's going to look at here in the part. let's say I model these as let's say I model these as grooved, just for example. And all right, I'll only do 2 of them, just for example's sake. So here, if you already have a development, okay, why is there an X on it? Because I changed something in the model, and the development needs to be just updated. What did I change? Well, I changed this from a bend zone to a groove, so the development needs to be recalculated. Why is that not automatic? Let's say you got 50 sheets here, with developments from all over the project, from the parts. You only want it to spend the PC power to update the one that you're looking at just now. You don't want every single one and the whole drawing to be updating when you're only looking at one. So here you can right click if you see the X and say update. You can also come up here to sheet metal and say update. Update here. You can also say, let's say you want every single one in the drawing to then be updated. You can call that up here. Otherwise, it's one at a time based on the one that you're looking at.
Is there a keyboard shortcut for that? In SolidWorks, it's I think it's Control Q. In AutoCAD, it would be you could do redraw or regenerate.
Probably assign one.
Okay.
By default, there's not. But let's see. We got sheet metal, and we got.
Because that would be something we use rather frequently. You know what I mean? Sometimes as we're making changes.
So let's see here. You could say the rules with the shortcuts is that you can't use one that's a system shortcut, like default from the factory, and there's not too many of them. You can see all shortcuts here. Again, do you know how I got to this? I came up here and I said customize quick access
Yeah.
toolbar.
User interface, right?
Yeah, and then here's where I said while we're working in sheet metal, so let's find sheet metal commands, and looky here, we got new, we got attach. It just works its way across bend zone. Down here we have sheet development, and here's where I can say I want update. Let's say you want to say update here. You can assign a shortcut here as long as it's not one that's already assigned by default.
Okay.
And you may run into that. I hope you don't, but you just might have to change something a little bit different from what you might use. What did you say it was? It is in
In
SolidWorks or
SolidWorks,
whatever.
you hit Control Q, which to me would be quit, but in SolidWorks, it's to update the drawing. In AutoCAD, there's a couple ways you can do a redraw, RED for short, or regenerate, REGEN, or REA for regenerate all. It's just a common thing that. Yeah.
So this command is specific to developments. We have another command that we'll get to that's specific to detail in sectional views. So if you want to update those. Redraw, we have one. Generally speaking, it's not really needed. What you might need instead is like a recalculate of your feature sometimes. If something's not responding, you can hit this one, which I don't know if you can assign a shortcut to the feature dialog here or not. I'll have to look into that. But here you could say if you wanted sync developments to say, I don't know, let's see if Control Q seems to be acceptable. Or else
Okay.
it would tell me X, it's already used. So let's
Yeah.
see if I do that, and then I come back here. I think some of these flanges I hadn't switched to here. I say mill zone and mill zone. So let's try it. Control Q. You have to have, I think you have to have the view active.
Or do you need to
Not happening. Let's see. What did I do wrong?
restart? Do you need to restart the machine?
Probably not.
Okay.
Oh, Q. Not working for me.
Because usually, like in the coding world, when we make changes in an environment,
E-
a lot of times they won't take effect until you close the environment, restart the environment.
Sometimes I do, sometimes I don't with us. And the key is to start figuring out what you can do live, and like everything else, basically you can't. You could be right here, because it really just is not responding
Yeah, if it
here.
works
But
with any kind of background containers or background environments, it will have to be restarted.
could be the issue.
Yep.
Yeah. But
And
I'm
for
hitting
something as
Control Q
sophisticated as this,
and
wouldn't
nothing's.
surprise me. Right.
So here you see it's changed based on these grooves. So now we got all those different colors. Maybe that's not quite what we had in mind. So here I can right click on this development view and say, let's change. It'll bring this dialog back up. Did it really lose my edge? My edge disappeared because I changed from a bend zone to a mill zone. So let me
Approved.
just reselect an edge. Does that make sense? Now this geometry changed, and my
Right.
edge, which was in the bend zone somewhere, no longer exists. So let's say I come back into here, and here's where we got positive. Oh, let me uncheck. You got positives from the top, negatives from the top, positives from the bottom, negatives from the bottom. So let's say here I used 90s. So I'm trying to figure out why I got some green, some red. So let's say these were from the top. So top and bottom. So these would be on the top, and these, let's say, would be on the bottom. Green dashed. Gonna make this red. No, we could say solid. Solid green. Actually looks okay. Why am I only getting reds here? Did I use the wrong tool? I might have used the wrong tool. One moment, guys. 90. 90. Oh, 120. Okay. I didn't have the tool. I wasn't specifying the tool I thought I had used.
Oh,
So now here we go. So it's following what I have here. So from the top, we got dashed. From the bottom, we got solid. Now we also have what's called, which is the front side. So for example, here you can say, so here my edge selected that this is going to be the front side. So I pick an edge on the front. Now, if you pick auto, you got some different options here where I know we haven't done this yet. You can put a directional symbol on there, like a processing direction, an arrow. You can put a coding on it, and you can use that coding feature to determine which is the front side. You can also actually just declare via a function, this side is the visible side. And you got a last one here with involving pattern marking lines. That's our weird way of saying like a laser etch for like which it's like what, an indicator that something else is going to be lined up here, either as part of the assembly or maybe not much for your business, but like if it's a weld in like steel industry, maybe that's where that could be used. So basically I said from the top is green dashed, negative on the top is green solid, and then from the bottom we got green dashed, and then for negative we got green solid. Of course, you can pick whatever you want. Questions? You guys following?
yeah, so far so good. Looks great.
Okay. So let's see. I'll close this out. That's fine. So dimensions, we talked a little bit about dimensions when we did that 3D plate, right? But here's where we can practice again here, do a little drawing with some views. So let's say I start off with some kind of frame. So here's my part. So I'm going to need to scale this down. Let's see what we're going for here. Something similar to this. So let's say I want to make this smaller. So here I can say, I don't know, maybe too small there. So you can put something here. Maybe a top. maybe we want to see the hidden lines. And then your development, you want to fit that here. So here I can say my development's over here in model space. Well, I could of course create a new development in sheet space, or I could say, hey, just bring that down to here. You see, whoop, where'd it go? Disappeared. Well, now it's down here and can be scaled as well. Okay, misclick there. Say get something like that, maybe a little big still, but
That's when you want them all aligned. You're trying to move them all.
yeah, that actually works pretty well in this case.
Yeah.
So something like that. I actually like this a little bit bigger, but you'd have to calculate something in between, or maybe we can get these a little
Can you-
tighter here.
Is there a custom function in there? Like, for example, a decimal? Can you punch in a decimal scale? Just,
You can punch it in. If you want to see it in these active, you'd have to set your whole system to metric, unfortunately. But here you can type in like what, I don't know, what you have in mind. Or you can say what.
I don't know. It's just, I don't know. Something like that. Let's just.
I'm not so good here.
Equals a foot.
But you can
What
say
if we
like,
want to go?
you could say like 1 to 5 like that. Or whatever you're thinking, which would probably
Okay.
make it bigger.
A lot of times I'll tweak it because in AutoCAD I tweak it by the decimal so it fits the paper perfectly like I want it to. Rather than having to go with a standard 1 to 5 or 1 to 4 or 1 to 6,
Mhm.
I can go in between all those, to find the ideal.
Yeah,
It'd be custom
you can
scale, just a custom
you can
scale.
certainly do that. The only thing is if you're trying to get in between these two,
Yeah.
you might have to do like some quick math to figure out what's the equivalent to 6
The
inches.
ratio,
Yeah.
right? Well, it probably won't be that, but I won't need to with something like this, I don't think.
What you see right here, more than likely, most all the time is going to be generated automatically anyway.
Mhm.
This is more the manual concepts behind how it works,
Okay.
and sometimes you might want to make a quick drawing manually.
Well,
It's good to know how to do both, of course.
yeah, we'll figure it out. It's just nice to know the functionality is there.
So standard dimensions work exactly the same as it did in 3D. Let's say, for example, we do, the variable. You can say, from here to here, from here to here. And I think you guys got some practice there on earlier exercises. So if it's okay with you, I don't know if we necessarily need to sit here dimensioning everything, so that we can move on. Okay, let's see. Did I miss anything, export maybe. So say you want to export this development. You've got two ways of doing it. You can say export a development view that's already created, which is this one. And here's where you could say, whoops, wrong way. Here's where you could say you don't want it complete, or only the contour. You see, complete gives you all the dimensions and whatnot on your export. Let's say it's going to go right into CAM. You don't necessarily need your annotation callouts on there.
That
You
was my
just
next
want to,
question.
yeah.
I think
Here you
we'll
can
do the 3D for build, but we're going to have a CAM. It's just going to have to get exported so Marco can use it.
So complete and contour. Now, if you had some cutouts and stuff in there, that would be included here. So, so complete, or we'll say simple minus the annotations. And here we have an export setting. I'm trying to think, what do you have here?
Previous configuration, CoBus, and ISD default.
Interesting that I don't have an ISD default. Okay.
I'll sell it to you.
Strange, because I think I have it when I say. Nope.
How do you not have something?
My thought is there. So we used to not have this. Maybe I'm getting ahead here. This settings export dialog. We used to actually edit a notepad file that was in the sys directory with all types of text in there defining how it was going to happen. I believe that was a 2022 version. We were doing the notepad file. 2023, they came out with this. So they made some changes in there. So since I had 2022 and then I updated to 2023, my thought is I took my existing settings and converted it over to work with this dialog, and the default. I've also used the same configuration favorites. So when they created that new default favorite, I used the same configuration settings database that I was using with 2022. So when I moved that to 2023, I didn't actually use that default that came with the, anyway.
Right, I got you.
I could get it loaded in there if I wanted to, which maybe I will. But for now,
I would have done the same thing as a user.
because you started now. We're eventually gonna create all kinds of settings, including your settings database here with all types of stuff in there, and you're gonna keep using this database moving forward from version to version to version, from year to year to year. Okay, anyway, so here we had export of developments. Let me get back here. So, okay, you have default. I'm going to load a general here instead. And you can then, once you have something loaded, if it's blank, you can't edit anything. You got to load something from your list. And then you can say edit settings. And these are your export settings of how it takes what exists in this development, and please ignore the strange graphical here. It's something probably on my side. So here's where you can say unit of length. Here's, you could say as in drawing, or you could declare one of these specifics here. Target version. Here's where you either want 2000, I believe 2000 and forward AutoCAD, or I don't really actually even know what this 12 is, but you probably do, Barry.
Oh,
Something a long, long time ago.
yep.
Yeah. Okay.
And 2000.
So creating blocks. So is it going to create separate blocks for parts, dimensions, hatching, symbols, or maybe just dimensioning, hatching, and symbols, or just symbols? So you got some options there. Here you could say, do not export a single part as a block. So you can say yay or nay there. I'll walk through these quickly, but it probably is going to take a little bit of playing around on your own to come in here and screw around with it. But here, export 2D dimensions as real dimensions, or are they going to be lines and text? Depending on what you want there. Although if you're exporting for CAM, you might not even have any dimensions shown on there. Because you don't want them. You just want the geometry lines, so that Marco can add the tooling and whatnot.
Right.
So the way this works, and this is just a default. This is well, way too much than I would think. But here's how this reads. You want what elements, and you got lines, text, or others like symbols, and God, that should not be German. I'm sorry about that. So lines, text, and symbols, other items. Here you could say I want it on a specific HiCAD layer, or I want all these items in the model to go to blue, and either be any line type or a specific line type. So here's where, let's see, I'm just gonna, all right. When you create this for yourself, I would get rid of everything and say, here's where I want, let's say you're thinking about this contour. You want lines on HiCAD layer 1, which I believe is what the setting that we have for those contour lines. Remember, it was in that development setting, and then extended options, and then right there on that first page, you had contour and processing, and inner edges and whatnot going down that list. So here's where this is important to remember what you had on that screen. So usually I'll take a screenshot of that screen and I'll come over here, I'll put it on the other screen, and then I'll think this through as I'm preparing these settings. So say you want that outer contour, I believe it was on black, and let's say we want this to go to solid, and we want to call that layer, contour, or whatever sounds good to you. This is typically what, I don't know if there's particular ways that your CAM program, usually it's already set to see things on certain layers, right, Marco? Now you could probably change that, but then that's extra work. So if you want to leave it alone, then we can conform the settings to work with what you already have configured on the CAM side. So just an example here. So let's say you put your outer contour line to something called contour. Then you come over here to the next tab, and here's where I'm just going to say, now here, I can't spell, contour, there we go. Sorry about that, guys. So here's where you're going to take everything, every layer name you have listed here is also going to be listed here. And here you're going to say, let's say you want to send that to, this is now the AutoCAD color. So this is going to be, I've got the freebie here.
Works pretty good. I've used it. It's
And
great
let's see.
for
I'm just going to
it's a
open
solid project.
something here. And then here's where somewhere we got colors.
Oh, you can hit LA for layers.
I don't think the commands respond to this free
No?
I think it's buried in here somewhere. We got
It's been a couple of years since I've ran that, but
here we go.
yeah, you had it. Where was it? Okay, I see.
I just grabbed it from one of the layers. So
Mhm.
here's of course your whole index. There's probably unique colors can probably also be arranged. But here let's say, so in here, black in HiCAD actually wants to go to white in AutoCAD. So here's where I would actually say I want this to be 7. Can't type 7. And here you could set a specific line width and DXF type. Let's say, okay, also continuous. Line type assignments. Here we have this pre-configured. Generally speaking, I don't need to change anything here. I don't know of anybody that it has, but you can. You can edit all these lines. If you need to add extras or something that we miss, change something. But basically, this right here is based on what's configured here. So you can change it if you need to. You probably don't need to. Here's where you can say fonts. You want a particular HiCAD font to go to AutoCAD font. I don't really know what these font files are, some kind of AutoCAD setting behind the font.
Your type fonts, they're a font standard ETF.
Yeah, so it's, you probably know, I don't really, but some kind of font settings, and you can additionally widen if you want to. Color assignment. Here's where you want to take the colors that are important to this development, or maybe all developments if you want to create some kind of standard. Here's where you're going to take the HiCAD and push it to so 7. Let's say you got light green is 3. I guess we're taking, at the moment I'm pushing dark green to light green. Is there probably also one of these other greens? I'm not sure if there's the green in AutoCAD used other than that one. I guess these are commonly used ones, I suppose.
Yeah, those are the basics right there.
Okay. So here we got 2 HiCAD blues. They're exactly the same, except they have a different number, and I believe the reason behind that is so that you can use both of these if you want. We also have some kind of lighter blues here. You can also make your own custom colors with RGB values or whatever. So that's also possible if you want. But so we got
Right.
2 blues here, which I believe allows you more capability here in your exporting. So red, anyway, 1, so on and so forth. So that's kind of how this reads. I know it's kind of quick, but I hope that sort of showed how you can create your own.
Yeah,
Um,
I appreciate that.
yeah.
It's nice to know that's there.
And if you want a nice read, we actually have a great page. I'll send you a link in a minute. Interfaces, 2D DXF, create DXF, and then we got edit export settings. So here, this page, looky here, goes right into full descriptions on everything in here. Here's what we just saw. This is we have a lot of good pages in here. Some are better than
Yeah.
others, but I think this is one of the better ones in here. I'll copy this link into the chat, and you can save that maybe in another document that you might have going with some notes or links or.
Absolutely. Thank you. I didn't know about that link.
Oh,
I feel like
the
I
help?
scored something today. Yeah.
Are you familiar with this help, or is this the first time?
First time with this one.
Oh, okay. So
I
your help.
browsed all your other documents, but for this one right here, because this is online, I haven't looked at any online stuff.
So
Really.
help. You can enter this page here by question mark
Okay.
and then help. You can also, let's say often enough, let's say we come into here, let's see if it works. And you hover over a button and hit F1. And look, I hovered over export sheets. It took me right in here directly to the page on that button. So hover over a button like export, and I say F1, and
I like that.
ta-da!
That's awesome. Does that work for every button? Every major button?
Every major button, maybe not every single one, but a lot of them. And the structure is also pretty good here. Look at how it's organized. You got all the 2D, 3D, point clouds, sheet metal, steel, element installation, which we're trying to get to. That's where you're trying to get.
That's the promised land.
The promise. You also have search box here. So search box, you can type keywords in,
Yeah.
like export, and it'll return you all the different ones that return the word export. So the search is good, but sometimes you get way too much here. Like I searched for export. Well, which one of these are the one that you want? I don't know. You'll have to investigate.
All right.
Or you could follow the structure is useful as well as, of course, the F1 key.
Yeah, I like it.
All right. What do you say to like a 10-minute break and then we move forward?
Sounds great.
Cup of water.
See you at 11:30.
Yeah, sounds good.
Okay.
This is the one you're talking about. Next front. So. Pricing is like $3, maybe it's like that. It's really. Yeah. Well. The same. Okay, process in front of instead of process, say something like just if you don't mind. That's our problem. Okay, all that. That kind of goes. So it's not really quite in the book. It's if you don't have a fly, it's not going to read that. Oh, okay. You would have had it. It'll be missing. Well, just do so to go stuff that. I mean, they try to next to it. We got new cattle or 50 guys. Or else that we have that's. That's amazing.
All right. And we'll be back. Take care.
Hey, guys.
I gotta make a call real quick. Give me 1 second.
All right.
Can you guys hear me?
Yep.
I bet.
All right.
Actually talking about an upcoming ACM job here. Okay.
All right. So next exercise here.
Start new word.
All right, say something, Robert.
I
Barry is so cool.
I can't hear nothing.
I hear him just fine. Very good. Something messed up. You
All
get it,
right,
Barry?
sorry about that. Yep, I got it. It sounds like my mic is being picked up by the camera, and for some reason my earbuds shut off from the computer and jumped on my phone. I thought there's no way because I manually disconnected that earlier. So, all right, we're back. Sorry about that.
No problem. All right. So I'm here on page 165.
All right. It
And we're
says
going. Yeah, sorry. What's that?
error. Use the home tab to apply Ubercrypt 165 of the PDF, or I'm looking at a different PDF. I'm looking at sheet metal. Sorry.
Oh, we're back in the
Yep, I got it.
general document, the intro to
Okay.
HiCAD or whatever it's called.
Just to let you know, there's an error on sheet metal, page 165. All right. Okay. Sheet metal panel, exercise 2. Get my HiCAD back. So we're going to start a new document.
New
I'm going to save
document.
this. Okay.
All right. I'm going to use the base sheet. You could also use a sketch if you'd like instead. Make 100 by 75-inch panel. Alternatively, you could probably use your own dimensions if you would like. Let's say we use ACM instead of the aluminum here.
Oh, we have the Lucabon folder.
What's that?
I don't think we have AS. Oh yeah, there's Lucabon. Just kidding.
What size did you make your base sheet?
I'm gonna, I didn't do it yet, but I'm gonna make
Oh.
it 75 by 100.
Okay.
Yeah, they got all the pre-made colors in here and everything. Huh? Rustic walnut. Got some of that the other day. Got some mica in here. Yep, do some graphite mica, West pewter. Okay. I've seen a lot of these colors before.
Yep. So this particular Lucabon library comes straight from them.
Yeah.
And I'm going to place this at the origin out of good practice.
So, I'm trying to find the Alucobond.
Oh,
I see it up there. Alucobond US. And you pick the Dolomite.
US, or I'm up here in the other ones. Did you pick a US,
Okay.
Marco? Just, we're going to use 4 mil. So you can pick any 4 mil in any of these ACM colors.
I'm only seeing 3 mil.
At the bottom here, bottom right of this menu, you got
Oh, okay.
different options.
I got you.
I made my panel wood grain, but I don't see no wood grain. What is this? But
It's,
playing
it's just a property of the material. It's
yeah.
now I have a customer that really wanted to see the colors, and of course we have the coding command that we haven't looked at yet, but you could apply the color. But again, the coding comes straight from Alucobond, and to be honest with you, I don't think they provided the right RGB values, because the color of the coding does not seem to line up with, does not seem to look similar to the color of the of that product. So he actually made his own textures and applied them to the panel because he really wanted that visual. But anyway.
So I've got the apply immediately now. It's showing up.
I don't know why it wasn't there on the. I bet one day you start up and the touch flange has the button there.
Yeah.
I've never not seen it there, but I also haven't paid much attention to it because I'm either giving a demo or training, and I don't want to apply immediately. I want to pause and walk through each setting and show the preview and then show how you apply. So I don't want to apply immediately in the case of a flange.
Right. All right, so I'm going to hit OK.
Yep. So, okay. So we got the base sheet, and now we can do the flanges, just like we have.
4 inch. What was the,
I'm gonna use 1 inch because I think that's more common to what, 1 or 2
Yeah.
inch? What would you use on a panel? Like 1 or 2 or somewhere in between?
we do typically 1, unless you need a farther return just to get back to the wall, we'll do 2 sometimes, but typically 1.
Okay.
Yeah, one.
So
Direct
here's where I'm
outer.
gonna get the settings, outer distance. Of course, it could be correct from before. And here's where I just say, what? Oh, okay. I'm gonna go back to DIN here. There we go. So here's where I'm gonna say first edge over here, middle mouse, edge over here, middle mouse, edge here, middle mouse, edge here, middle mouse. And I got all 4 of the flanges with the dialog box staying open. Now, if you close it, that's no problem. You come back up and just hit the button again.
All right,
Oh.
so now I gotta click the,
We want them coming up or going down, doesn't matter.
I would think going down. So this is the face of the panel.
Okay.
So if they go down,
I'm always thinking of the other side, 'cause I'm cutting.
yeah, I understand that.
Or middle mouse, not right click. Middle
Oh.
mouse.
I was forgetting to hit the middle mouse.
I know.
You got to hit it after each one?
Every time you add a flange.
Yeah, unless you had that phantom apply immediately there.
No, I don't. I see. I was missing the middle mouse. I lost my dialogue. Okay.
Click like the top bar. Sometimes it hides for a minute.
Got it back. I think I might have clicked the wrong edge on one of these. No. I want to start over. No, I got it right. Okay, let me go back. I can just open it up again.
Yeah, I mean that's fine too.
All right. I got all 4. Sides. Okay, we're good.
Okay. So you may or may have noticed we got the flanges here, but the corners not so great at the moment. And let's see, on the flanges, oh, since this is ACM, maybe you guys noticed this or not, I didn't think about it. We probably need to put the grooves here, milling edge zone.
I came up with it.
Okay, then I might have remembered one of your last actions.
Actually, no, I think I'm in the corner miter feature. That's why I did it. Yeah, I automatically put the V groove in the corner miter.
All right. So how'd you get there? You do the V group.
Opening up each one of these flanges again,
Mm-hmm.
and
Right.
I'm saying here I want mode to be, we have it on bend zone, I want to slide over one to
Okay.
what we call a milling edge zone.
That didn't seem to, okay, I see how it didn't help the corner. Yeah, okay, mine looks
The
just like
corner, the
that.
corner got worse technically,
Yeah,
which is a moment ago, what reminded me that I wanted to use grooves here is because, while the corner wasn't perfect by any means, it looked a lot better than it does now. And
yeah.
I was expecting this.
Hmm. That's what I got.
So what we have here that sounds like Marco's already used a little bit is we have corner miter.
So we need to change that.
What do you want to change?
The vertical miter there on your screen. You know that joint, the vertical joint right there as you're looking at it, it's vertical. Because the parts are clashing right now, aren't they? Yeah,
So all we did was added flanges. So
right.
flanges were added, that's it. So we got more work to do, yes, but we haven't done it yet. So
Okay.
we have corner miter here, which is going to help us here.
Right.
And I imagine that this is somewhat similar to SolidWorks, but I've never used sheet metal in SolidWorks. I don't really know. So,
Me either. I haven't got that far in SolidWorks.
oh, okay. So we have quite a bit of options here. You can look at the images. Not too many of them you're gonna like so much, but we just have a lot of capabilities here. For ACM, you're generally going to use these three because these three allow grooving of this corner here. It'll groove the inside. But the way this works is first we need to identify this flange and this flange. Now, here's where I know that I have a different setting active than you. What you have when you get close to this front edge, for example, the arrow's not going like that for you. The arrow's going out, right?
True. Yep.
Yeah.
More like this.
Yeah, it's going horizontal.
Or like
So
that,
mine's
depending on
going.
the edge.
Yeah, that's what mine's looking like.
Now you can right click and switch to say front edge or back to longitudinal edge.
Okay, so we definitely now mine's vertical.
Longitudinal edge, you need to select it this way. You want to select your flange. So let's just say this is a horrible setting, but let's say this is how you identify your edges using longitudinal. If you're using front edge, you do something like that. Here's what I'm getting at. There's a default that you can set. So it used to be that longitudinal, like what you see now, was the only way to go. And somewhere around 22, 23, they have this front edge option, and the front edge became the default. Well, I want to use it like this, which is what I was already used to. So I came into my sheet metal. This is my settings configuration. And I made this identifying front surfaces. You can pick which way you want to be your standard.
Okay.
And so I have the opposite of the default selected because that's what I want to use. So what I can do is I could either change mine, I think I would have to restart, or I can just right click to mimic what you're doing. Or if you like the look of mine better, we could just change it on your side to be like I have it. But you probably don't know which one you like better yet. So
Right.
what I'm going to try to do is I'm just going to right click to activate what you have. It's a little more
Okay.
annoying on my side, but at least it's going to mimic more what you got going on your side.
Okay.
So here, so look at this. This don't look so great, and that's just because of the option that we have here is flushing the inner edges. This is more for a non-bend zone type of situation, or non-milling edge zone. So go ahead and click down. So top right option here and top right option here. And here it's going to display either a tool, or if it's blank, we need to select a tool. What do you have on your side for this box here?
I've got standard groove form. Oh, mine was blank.
Okay. Do you
Mhm.
remember what tool that you do you know what tool you would use here, or do you remember what you used for your flanges? Assuming it's the same, maybe it's not.
Here it shows the 90-degree, around 90 bend.
What's going on here? That's not what I had in mind. There we go. So you can also put a little clearance in there if you want. If you zoom in to these flanges, you know, you can put a little
0.03.
amount of clearance, or you can keep it nice and tight, depending on what you want. Bend
0.0.
zone adjustments. Here's where you get different results here up top in the bend zone, depending on which one you select here. Now, longer flange, like you see here, overlaps a little bit, but I have a nice command to trim that in a minute. You can also look at, for example, bulgy, and you can look at the diagram of how bulgy looks pretty good. But some people don't like the way the development comes out with bulgy. You also got linear. Drainage is not appropriate here. Or you got no adjustment. Most of my customers use plainer, longer flange, and then we trim this in a later step to make it nice and tight.
Okay.
So a little bit of summary. So if you're using ACM, you're probably only going to use one of these three. The difference between this one with neighbors and this one is this one's only going to be a specific to the flange that you select, where here you see it's actually mitering all those
The whole
everything
corner.
with attaching flanges as well. This one's probably going to be your go-to. So this one, and then you want to be able to mill the corner here. I don't know if you've rotated it to kind of look at the preview here. And then you pick your tool. And let's start with this longer flange here for the moment. And you get a result like this. Now remember, you can change the geometry of your tooling. So if it's maybe not quite what you're expecting, remember that you can still do that.
Okay.
Okay, so now here under cutoff is the trim corner command that I was talking about. Dog just threw up on the floor. That's great.
So you pick the center one.
So you can do 1, 2, or 3. So the center one's for 2.
Okay. And you pick the 0. Do we have to select the bend zone for both?
Yes. Yes, so you say 2 here, and you pick 1 bend zone, 2 bend zone.
Okay. All right. Well, that looks better.
So try applying that here on all 4 corners. All right. While you're doing that, hey, give me like 2 or 3 minutes, guys. My
Sure.
dog just threw up on the floor.
I was wondering what you're talking about. I thought I
Yeah.
misheard you. Poor dog. Hope
No.
he's feeling better.
Yeah.
Is she?
He likes to eat way too fast, and then about 15 minutes later, and then he'll drink a whole dish of water, and then 15 minutes later, blah.
Oh,
I got a cat that does that.
Sometimes he licks it back up after he throws it up. It looks
Ooh.
like today he was only interested in licking about half of it back up. So
Oh gosh. What's his
I've heard,
name?
I've heard it's because they get embarrassed by it and they don't want you to see their throw up, so they eat it to hide the evidence.
oh,
What's,
could be.
what's
don't
her
know.
name?
Huh?
Dog's name? What's the name? The
Wyatt.
dog's name?
Wyatt.
Huh?
He's a Wyatt. WYATT.
Wyatt. Gotcha.
He's
Cool.
an Australian cattle dog. They call it a red heeler.
Ooh. Okay.
There's also a blue heeler, which has kind of a bluish tint to parts of its fur.
Yeah.
He's look not quite this, but it's lighter than this, but he's got sort of light and a little lighter than me, mixed
That's
into his
cool.
coat. All right, just a second.
All right. Yep. You catching all this, Marco?
Yeah.
I'm following along, but it's going to take some repetitions for me to remember all this.
Yeah.
But I think between you and I will be okay. And
I have found that definitely starting these exercises the day before, at least attempting them, has made things much easier too.
yeah,
No, I don't really know what I'm doing. I'm just following instructions, and then he re-explains it and shit.
Right
Really
now.
instruction clicking.
It's gonna really set in, I think, when you start, when you're isolated.
Yeah. But I want to get these freaking scripts built in, or just shit out the panels, man.
Yeah, right?
Like I already played around with develop on that panel we just did, so. Friggin'.
So when we're saving these, where are we supposed to save them as? I've got,
Been saving them into the drawing folder in the XCAD transfer.
what format?
I guess that's the SZN, just as the iCAD, but we would have to do export to DXF and then probably create a separate subfolder within that one at the DXF drawing with panels or whatever.
I'm not
Imagine,
seeing that.
imagine you drawing them out are gonna have to save them as the SZN standard
Mhm.
iCAD.
I'm gonna share my screen.
And then after you save yours,
So tell
I
me,
would-
right, when I go to save,
yeah, I think it should automatically be you're gonna save as. Just click save as, not the drop down.
what's that at? Oh,
Those-
just click
Yeah.
it. That's it. Okay, I see.
And there you go, that's SCA.
Yeah, so it's gonna save it as that, and it's going
I think
to,
typically your drawings will all be saved that way, and then I'll open up HiCAD, flatten them out, and then export it as DXF to upload it to AlphaCam, but it's probably gonna end up being. You can do all the conceptual, get the wall all drawn out. You don't have to worry about flattening or developing. I'll end up being the one doing the flattening.
right,
As long as you
Sounds
get
good
those
to me.
measurements freaking nice to begin with, and it'll make my job freaking squeaky.
well, if you could do that, that would help me a lot too.
Sure, there'll be the smaller jobs too, that they'll just be kind of feeding me the measurements and instead of drawing out the whole job, we'll just be doing a
Mhm.
little one wall at a time.
All right,
All right. You guys make that okay?
yeah, is wide all right? That's just par for it's an everyday thing for Mr. Wyatt.
Oh,
How's your dog, Marco?
Yeah, my dog, I think's some sort of Aussie mix or something. She's got the white with liver spots, and she's got a little bit of a look of the Aussie face to her.
What's the name?
My dog,
The dog set. Oakley, that's right.
She
He's a
likes
good dog.
to run up behind you and nip at you too, which really makes me think she's an Aussie mix.
She
Yeah,
was good for me when I watched her.
Wyatt's a herding dog.
Yeah, that's when you start
So-
playing with her, she'll run up behind you and nip at your freaking hands and legs, and I'm like, stop it. Good dog.
All right.
Yep.
So you guys do okay with the corners and trims and
Yeah.
Why does your feature look so much bigger than mine? Oh, how much sheet you are? Oh. Well, oh, there it is. Now my features look good. Got it.
We still got another trim function to do, right?
did you not do any of these trim corners?
Well,
I got it.
okay.
I don't
I must have
think
missed
very-
something.
Yeah,
I mean,
I don't think,
I got one corner good. I didn't do the other corner good. And go back to. Now I can't find the. Oh, there it is. Trim. Is it? That's not the same trim, is it?
no.
Are you looking at my screen?
No, this is mine. Go ahead, share yours.
I've got one corner good. It's
Okay.
that's that one. No, sorry. It's the first one I did. It's right here.
So I can tell you right
Yeah.
now, you did one miter and 4 trims. You need 4 miters and 4 trims.
Okay. All right. I know which one I did. And so, but
And the miters need to be done before the trims.
okay.
But that does not mean you have to delete your trims. What you can do, and you probably didn't know this yet, is that you can take this feature insertion point.
I can't see your
and you
screen
can,
now. Oh, because I'm
okay.
sharing mine. Hello. Sorry.
So
There
here
you
you
go.
can take this feature insertion position, and here I could say I want to
Oh,
move that up, and it's only it calculates from top to this position. So look at what I have here. I'm back to only my flanges are created. None of my miters or trims are done. You see how now it's building this one, and so on and so
yeah.
forth. So you want to take that and drag that up to just under that first corner miter that you did.
Right. Okay, we're there.
And then
Now, can't remember where that trim function was.
it's under cutoff, trim corner.
That's what it was. Cut off. Okay. Hello. Trim corner.
I wish it was the
Yeah.
top button. I wish they had made trim corner the top and put whatever this is in the menu. But
All right. Let me get on. What can I share my screen?
yeah, sure.
Okay. It's because I did this function before, but where was the miter function? What I did was I got this up here right under. We got to add more of these. So I go to cutoff.
Well, you want to do the miters. You actually have all the cutoffs, although we'll see how the model behaves when we apply all here.
I got you.
There you go.
Yeah, I could have swore I did that. It was like this one and this one.
Yeah.
Oh,
That's
maybe
good.
I didn't. Was it because I didn't select? And all I did was hit these.
No, you want to hit the,
Besides two, then, huh?
yeah.
All right. So do I need to undo these? Because undo is impossible. Okay, let's go to corner miter. Oh, we've got that selected. That selected. I didn't. That's not highlighting. All right. What am I doing wrong? Select first flange, which is there,
Yes.
right?
So no, front edge, Barry. So remember, you didn't have to end it. You just could have clicked the little eye again. So that's correct. You want that, and then the other one. So
This one. This one.
yep. So click. So you have one of
And
them,
click.
and now you do the second one.
And apply. Or middle mouse click. There.
All right.
Gotta do the other
That
one.
look,
too.
does that look right? All right. All right. So
Yep.
I got it right on the first one and somehow missed got it right there.
All right.
And then this one, we got to do that again. One corner miter. That got that. We're going to select this one. And we're going to select that one. Apply. Okay, we're good. So there's
So now you can either drag that. Do you have one more to do? You got one more to do.
one more. Yep. That one. That guy and that guy. Okay, now I can move this down here. That look about right?
Yeah, now look at each corner to make sure it probably calculated fine. But since we went back in time, so to speak, and added something, I always like to
Right.
verify.
Gotcha. That looks good. This was the first one I did, successful. So that looks good. Back over here. That looks good. Okay. I think we're all right. And now we're down here. Okay.
All right.
Yes, sir.
So here's another way. Instead of dragging this around, you can say right here, calculate to end, and it'll fly down. You can also say, let's say you right click on a feature and say calculate up to, and it'll just jump up for you.
Oh,
So you can click and drag, or you can right click and say calculate up to, and then you can just say, calculate to end.
all right.
So if you miss a feature, it's real easy to go back and edit and then
Yeah,
recalculate.
Also for troubleshooting, when we get to the parametrics, sometimes you get interesting behavior and you want to rearrange the calculation steps to either fix something or improve something or get rid of an error. So it makes it real nice to be able to do that. But it calculates top to bottom or top to insertion position. This is also useful, and we'll see that later, is let's say I go all the way back up to the base sheet because I want to create what's called attachment points so that you could attach a stiffener parametrically to this so that everything moves together and jives correctly in the parametric model. Like right now, say I decide to attach points now. Well, I don't have nice sharp corners. Yeah, you could start clicking other corners or doing math to get you there. But, here, I want wrong button. Sorry. Here, say calculate to. Now I got nice sharp corners. And the attachment points can be created right here in the calculation order so that even when you get all the way down here and you got curves and edges and all kinds of stuff going on in these corners, the points hold because of the order that they were calculated in.
Okay, I got you.
And we'll, of course, I know that made maybe just a little bit of sense there, but we'll dive deeper into that. All right, so let's see what the development looks like.
We got a set numbers and months or mentioning from there.
And I kind of skipped over this, but looky here. You got a
Yeah,
little favorite. You got a star here. So everything in this menu can be saved. under a standard of some sort, so that you don't have to navigate through this every single time. You just pull it up and say, I got way too many here, I know, and click on one. So another thing about these developments is this is a 3D development. You can actually see your grooves.
So, there we go. Well, it's showing up. Oh, I gotta shade that, that's right. Click that and then shade it. I put my, oh, there it is.
So you can change your view representation just like any other view to shaded, for example, and this thing you can rotate around just like you can any other view.
Nothing's happening when I do development.
Would you like to share?
Yeah.
Yeah.
Well, I hit development. Maybe I just didn't hit OK.
Look, it says select edge. You can go to automatic. Remember, the orientation will be automatically selected, or you can select an edge if you wanted to go a certain either vertical or horizontal based on the edge that you pick.
I'm fine with automatic.
Okay, so switch it back to the automatic one. Okay, now you got to place it somewhere with just a click.
All right. That's what it was. I didn't place it.
Could be.
Click
See,
what?
you still actually haven't made it yet. So you're still in like preview mode. So you could still make adjustments and hit the preview button to see what it looks like. When you're satisfied or ready to actually create it, then you say OK or apply.
What's happening when I hit preview? It just blink.
Well, you already see the preview there. Your development's there on the right.
Oh, okay. I
The
see.
preview's already been generated.
I gotcha. I got to change that background.
Okay. Yeah, if you say OK, we can.
Okay.
So
all right. Now we got it.
Up at the top right, you went to probably to pencil and paper and then color settings.
That's probably where I got it.
And then
Graphic window.
Graphics window, or you might have gone to open configuration. But you might have just said here you want your background to be
Is it? I think this is all black. You go. Holy smokes! All right, let's come back. Come back to Earth.
Let's do it.
There's low default at the bottom. That might take you back to that blue.
Yeah, like you
There
could.
we
Yeah.
You're so smart, Marco.
Oh, I changed mine. It sucks. Hold on. I don't have that with you. iCAD Classic.
Mine's special.
You did something weird. I don't have any of those menus. Okay. All right, whatever. I got what I want.
Okay, me too. Okay, so
All
that's the development view.
So what I was saying about development is that that might look 2D to you, but it's really just like any other view that you can rotate around. You can change the representation. You can physically see the grooves.
Upside down.
Yeah, we can flip it around with a setting, which is probably what you'd want here,
Yeah.
so that Marco cuts the grooves on the right side of the sheet.
Yep. A lot of times I give it to him upside down, and I still try to blame him. So, all right. So how do we
That sounds good.
flip this?
Say, hey, I'm not the one that cut it.
Right? That's what I say. All right. So I'm noticing I'm hitting this, and it's changing the view here fine, but this is oh, was I looking at that wrong? I'm just trying to hit it. Oh. I'm going nuts. I'm sorry.
So if you want to know what view you currently have active, look over to the left in your views, and you'd see that right now your development view is red. So that's the one that is activated.
Okay. All right. So how do we flip it all the way over?
I did that
Okay.
in the development
So-
menu.
If you
Mhm.
right click on the development and go back into the settings menu,
Yeah. Invert upper side.
so Barry, right click on the development view.
This one? No, that's a
The
development
view.
button. Which one is that? Oh, over here?
Okay, that might work. They're one of those top ones. It's not used. I usually click on the view in the model space, but there you say update. The next one was the next one. Okay,
Okay,
no,
keep
that's
that
not what we
big.
want. Actually, come out to the model space and click on the development.
Click on this.
In the drawing area,
The part that we developed. Yeah.
Okay.
right click now and say change development in the middle. Now you're back into this menu, which you can make any kind of edits at any time. And here, number 5 at the top, you can say invert upper side. Here it says no. You could change that to, I'm assuming yes is in there.
It's about X and Y.
Yeah, so here you can flip this around. Yeah, maybe the x-axis.
Okay.
Yep.
Well, that only does the development though, right? Or does it do both?
What do you mean
Development
by
and
both?
well, I'm looking at one thing here.
Okay, that's just the standard view that you're modeling in.
This is the development here.
So I guess the answer is yes, it only does the development.
Okay. Interesting. I think that's what I was getting at because I was looking at this thing like this. I'm like, wait a minute. Why is this over here like this, but this is flat? These aren't synced up.
Well, no, every view can be positioned individually. The development is
Okay.
no different.
That's trippy. I see now. I got it. Yeah, that
No,
is not like anything I've seen.
chances are you're used to looking at your development from, we'll say, I don't know, top view or whatever you want to call
Right.
that. So if that's what you want, well, that's what you get right away anyway. So
Right. Okay, so now they're both. I guess not.
so zoom in on your corners of that development. Just take a look.
Am I still upside down?
You're still upside
Probably.
down. I thought we
Me
did
too.
you rotate it around manually, or did we
No,
miss
I didn't.
the setting somehow?
Must have missed something. Well, let's make sure we're still up. We're really upside down.
So you can do that by
Oh, we're
clicking
good.
top view.
We're good. I flipped it, and so
Oh, okay.
this is the top view, and then we're going to go to the side and look at it. And
Yeah.
Yeah, we're good.
All right.
Sorry about that.
No, it's fine.
All right. I don't forget to share your screen. Yeah, there we go.
All right.
Dude.
We're on the other screen. I'm looking around for the book and it's over here on my right screen.
So you got 3 of them?
I got 3 of them. I'm in too many meetings. Like it's really hard to,
Yeah.
like I can do all my work on 2, no problem. But
Yeah.
when you're trying to work and be in a meeting, it's like kind of like what you were running, like you were commenting on
Yeah.
earlier.
Yeah. Like to have you guys on one, the PDF on another, and my work
Yeah.
on another.
So yeah, at home I got 3 24s side by side. At work I got 2 24s and a 27 in the middle.
Nice.
And of course at home I paid for the home office equipment. Obviously at the office they provided, but
Yeah.
all right, some cool things that we can do. So we have here something. Let me activate this view again. We have something called, at least I hope you have, called BenSim. Do you have BenSim here? Hopefully it's not grayed out.
Mine's grayed out.
Really?
Most
Let's see,
everything.
I know it's not. I was on the development view, that's why.
Okay.
Yeah, me too.
I have to be careful here because BenSim is the premium sheet metal package. There is a standard package that we don't sell too much of, and then sometimes I get into training and I'm clicking on things and they're saying, nah, I don't have that.
Okay, yeah. If I click on the sheet view, it shows up. Or model view, view 1.
Model view, it should be available.
Yep, it is.
On the sheet view, really? It's not there?
No, it's there on the sheet view. It's just not on the development.
Just not on the development. That's correct.
Right.
Because development view is a special view, so to speak.
Okay.
Okay, so BenSim. So what is this?
Been
It allows
simulated?
you to flatten your part temporarily. And look, it puts a BenSim feature step. You flatten the part, and then you could do, for example, let's do a sketch first. Some kind of unique, kind of interesting subtraction. You could do something like this, or, you know, like that, or interesting still about a nice n-gon. Let's say we create a triangle. Okay, and then we subtract, selecting this sketch. And so you can put the subtraction through, do a BenSim again to bend it back, and look, your shapes, it bends back after the shapes have been created. So you can do some unique things with this. My demonstration might be a little silly, but hopefully the concept is clear.
Yeah, it is. So that's a way where you could you could put some of those patterns in there and test it before you actually see the part. Is that what? I'm assuming
can-
Ben Sim is short for Ben Simulator, Ben Simulation.
Bend sim is to temporarily flatten the part to allow for further processing.
Okay.
So if you do a bend sim, you gotta bend it back at some point. So if you do the bend sim here, like you don't just not bend it
Okay.
back. You don't just
Yeah.
continue working. Like you bend sim, you do what you want to do, and then you bend it back.
So this is the proper way to do it.
This
Or
is the
if you come
proper
in,
way if you had a unique shape that you wanted to kind of apply to not only the front sheet but also to the flange in a unique manner, such as this.
Okay. that is really cool.
So say you
Used
got
to
like a
having it.
pipe, like a pipe coming through, going through a panel or something.
Mhm.
Oh, hold on, I got 2 tanks finding. Holy shit.
What did he say?
Got a tool
What'd you
change
say,
on my
Mark?
router. I gotta adjust the misters here. Thing's been running all day.
Oh boy.
All right.
So if we're gonna do anything on a bend like that, this is how we're gonna have to do it. But if we've got other patterns in there, like for example, a cutout that still has to get let's say there's a cutout in the middle
Mm-hmm.
that we
Now
want to fold.
you can still just do, let's say, subtraction. You know, let's say it even God, I didn't intend for that to be that big, but
Can we do it square or rectangle so it's got edges to fold? You know what I'm saying?
mm,
We may not be able to get the full fold on the corners because it's an inside bend. Maybe we will.
uh, okay. So what type of shape did you have in mind?
Let's just go with a square. Just do a
Okay.
square cutout with folded edges. Yeah, we're not going to get the corners, are we?
What do you mean by folded edges?
But will it
Oh, you
automatically
know,
put a flange in there if you notch out the corner?
yeah. No, let's just put a square in the middle there. Cut a square
In the
out.
middle of the panel?
Yep.
I'm just gonna eyeball it if that's okay.
Yeah, that's fine. Yeah. And get that cut out and then have the edges folded. I guess you can't because that's what I said. You can't because of the corners.
Oh, so you would cut this out probably.
Yeah.
You
And
saying
then
you saying these edges would fold down like a flange?
just like our outside flanges. Yeah.
So then you would do flanges like you've been doing.
Yeah. But you can't do it because of their inside folds. But when you go to flatten those out,
You don't have material.
right.
So how would you do it then?
How have we done? We try to avoid that first of all, but
Yeah.
we have had to do situations similar on a
I
limited
just
basis.
I run a miter line, and then we end up with like an open triangle, and you just gotta make a little
Right.
like filler piece to glue in or
Yeah.
something.
We have that. And it's a lot of fancy machining because, of course, you want to make it so you can't tell that, there's a lack of material there. But but yeah, that's what I was getting at.
Yeah, because here's your development. I mean, it
Right.
it builds what it can.
Yeah. Well, that's good though, because then we don't have to figure that stuff out if it'll build what it
So
can. I see
so
it's
what
doing
you
it
might
there,
could do
but
now. So now let's say you flatten it.
yeah, see, that's the part that they're clashing. There's just not enough we'd have to run one side and then fill in a gap fill the void with another piece of material. Custom. We got a Bondo guy that does some pretty cool stuff.
So you could either subtract the material out to get the model correct, or you could say
Right.
the hell with it because, you know, this is what you're going to get anyway. But if you wanted your model to appear with what you're building, then yeah, you can subtract out the corners. You could do, I mean, you can always use subtraction. Might not be the best way here, but just off the top of my head, you could say theoretical, and then, you know, 135, and then subtract. Come behind it for this side. You got trim, probably not quite. You could use maybe even chamfer the corner. Might be an okay way to get a 45 or a whatever you want to call this 45 degree. How would you have handled this in? Well, you said you didn't do sheet metal in.
Well,
Did
in
you?
SolidWorks, no, I didn't do that in SolidWorks. I would do that in AutoCAD, but it would be just like what you're starting to do is we got to subtract a corner and however we want to put it in there, either a square or a bent piece.
Mhm. I was thinking if, like you said, a chamfer here, even though that might sound a little strange, you could calculate whatever this needs to be. That might be a little quicker than subtract.
It's pretty easy when I do it in AutoCAD 3D, but I'll do it in AutoCAD 3D Space, but I use just straight, what do you call them, edges, lines. It's hard to explain, but it's really
Yeah,
easy that way because when I go to I'll flatten it out like our dev or development here, and it's really easy because you're basically flattening it out, and any
you
kind
can
of overlay
also
I'm able
you can
to
also
manipulate.
you can also process the development itself, which I must be honest with you, I haven't done much of that. Let's see, draw, change, subtractions. That's not what I had in mind. Oh, that's deleting borders or subtractions. Let's say fill it, chamfer, if there's not an actual corner.
Marco's probably done it about every way you could do it.
Oh, yeah.
I don't think
Oh,
there is
Me.
subtraction.
one way better than the other.
Our installers are great with backer rods and silicone too.
That's hilarious. Well, they think they are anyway.
Right. They don't complain to me when it gets done, so.
No, and I don't complain that it's done. As long as the customer's happy, I'm happy.
Paycheck clears, I'm good to go.
Yep. Next project, please.
Just curious here.
Yeah, it's I think I know what you're doing.
So, okay, need to come out farther, but I'm actually doing a subtraction on the development, not even on
Okay.
the view. And here, look here, the sheet development now has a feature step off of it. And let's see here, I could say I want to, actually I can edit this right here. I wanted to make that a little bit different. But it's only happening on
on the
the
development.
development. So that's kind of unique.
Yeah, it is unique, and we try to avoid that. But there's some times where we just gotta eat it and do the best we can. I'm curious how other companies do that. Have you seen this before, or are we a special breed? I know we're
Or
special.
they
He
or
says
they
we're
figured
special.
it out, or they just did it on their own somehow and didn't ask for help or didn't tell me about it.
Yeah,
That's possible.
We
I was
get
just
a
curious if
couple,
it.
when we get a couple bigger inside miters, say like a parapet wall up top or something, we've actually made it out of two separate pieces and do flanges in there to try to attach the two pieces together and make it look like an inside bend. But
Mhm.
Or like if you have a unique curved facade, you're sometimes taking two pieces and gluing them together, right?
oh yeah,
Yeah.
glue some angle on and screw them to that angle and all kinds of stuff. The Florida though is real tricky with the hurricane code and stuff. They don't want to see too much glue on a panel.
I could see
Yeah.
that. I got a guy out in Arizona. Um, he's got a team of 7, including him. So he has 7 licenses of HiCAD, and he knows quite a bit. He's maybe not on settings and stuff like that. He's maybe a little weaker, but he's doing some projects out there, and sometimes he shows me a thing or two. Now, even though I trained him a couple years ago.
Cool.
He's one of my go-tos as far as asking specific production project questions. Unfortunately, I operate here in Fantasyland. You know, demos and training um, and
You're doing a
options
good job, Robert.
configuration and what's that?
You're doing a good job. Can I share my screen for a second?
Sure.
Check this out. This is at the airport.
It's not sharing yet.
It will in a second. Oh, did I not pick the right screen? All right, let's go here. Am I sharing the right screen now?
Right now I see your PDF and your email, so I'm guessing perhaps
Okay.
not. Now I see. Okay.
This was a fun project, but only fun after it was done. And there's some unique challenges on this. The nighttime view. Trying to get a side view. This was pretty tricky. We went out there, measured. It's got a 5/8 thick tubing, stainless steel subframe.
Okay.
Wrapped, it's crazy. $2 million wrapped with 3/4 inch plywood, and then it's got our ACM, and underneath it's got lights and speakers where people could come in and sit, watch the airplanes take off,
Mm-hmm.
and listen to air traffic control.
Oh, huh. So the whole thing was $2 million, or just the cladding was, and the support structure was 2 million?
I'm not on the money side, but the newspaper said it was a $2 million project. So,
Okay, then that's probably everything.
yeah. And, it wasn't, there were some challenges on it because some of the wood had some bows and warps in it. I mean, like
Oh, of
a
course.
couple inches across that span. So, oh, not this project.
That looks nice.
Went the wrong way. Yeah, we built all that too. All this, built that. I have a 3D model of that. That's pretty cool. Right here. I don't know if you can. Oh, you can't see can you? Can you? No,
If you
because
own
you're
it,
sharing the screen. Anyway, yeah, we did all that, and we did this ACM too. That doesn't look all that great.
That's just a site. That's like a line in the
Oh,
sun. There's not really a big ass line in there.
okay. All right, yeah, but
That's
this is
what I thought when I saw the picture. I'm like, oh,
that's all aluminum. That's not. Um, that's down. Where is this? St. Peter, Naples. It's Clearwater,
yeah.
Petersburg. But anyway, yeah, I didn't mean to show you that. I just want to show you the ACM crazy stuff. Does your Arizona do crazy stuff like this, or
mm, I don't know. I think it's pretty.
well, the
Yeah,
local
sometimes he
bond
gets unique projects. Yeah, but I think for the most part, it's I don't know.
pretty cool
I don't know if
stuff
there's
like
such
that?
a thing as standard, but
Like a
Yeah.
building facade typical. We get a lot of artistic stuff here in Sarasota. A lot of art is an art school and a lot of architectures will send in like the sculptures they want wrapped in ACM and stuff.
Yeah. What is that one? Okay, that's it. Okay, this is the other end of that same thing.
Yeah.
I see now.
yeah.
Yeah.
So you had to glue. That corner's got the couple pieces, right?
Yeah, the bottom is a radius, and then we have the Alu bender machine, which creates a rolled seam on the bottom of the panel. We're able to bend that around and attach it to some aluminum frame underneath.
Pretty trippy.
The wood guys
Oh, that-
actually just screwed us on that.
That just got installed. That thing.
Hmm.
That's AutoCAD right there.
We also have some nice commands for staircases, or basically for something like that. That would be like parametric modeling using mainly 3D commands, but you can add some nice parametrics to it to help you out.
We've got one. It's starting here real soon. Another CAD drafter drew up. It's one like that, but it's going to get, believe it or not, um, it's an indoor double decker.
Hmm.
That's going to get. I guess the owner doesn't want to know that it's made out of aluminum, so they're going to drywall the whole thing, and they're going to have I think stone on top of the aluminum treads.
Mm-hmm.
And then they're going to drywall the center pole, drywall all up underneath each tread. And man, I want to see a picture of that when it's done.
Yeah, RIP that guy.
Yeah.
So
Anyway,
sure.
I'm sorry.
Mind
I
if
didn't
I
mean to-
share for a quick minute? So here's
Yeah, go for it.
here's
Oh yeah,
here's a little demo.
that's really cool.
I actually have a video.
This is all done in HiCAD.
Yeah, which I'll speed up a little bit here. So the idea is that you're talking along with it, so that's why there's no sound. So let me move that forward here. So here you got some
How large is that
sketches.
video? Is that like a
12.
huge video?
12 minutes.
12 minutes.
I mean, like file size? I mean, could you send it or share it somehow? Is it on YouTube?
It's 135 meg. I would send you a OneDrive link to this very location is how I would do it.
Man, if you don't mind, I'd really like to see that.
Actually, I can just copy link, I think. Not necessarily share. Not Dropbox. Copy link.
I'm in a meeting. All right. It's over in about 10 minutes if you come back in 10 minutes. Okay, cool. Yep.
So I put it in a chat. I'm happy to share the file with you too. If you
Yeah, I appreciate it. I would study the heck out of that.
like this is just
help
something
me a
that I
lot.
did to show prospects, so it's not any kind of special
Great secret.
proprietary anything.
Yeah.
Let's see.
Okay.
So
Open the chat.
basically you start some kind of thread here via sketch, and you can create that, and then using just sheet metal like what we just did, so you can say flange.
Oh, yeah.
They will do a flange on that radius outside. Does it know how to create a flange along a radius or?
On a curve?
Yeah. Will it not do it?
No, we can't do that at the moment.
Okay. Not that it
You
can be
can.
done on a sheet really anyways. I just wondered if it'd even try to do it.
I think they want to come up with something to help out with that, but it's probably on the list. So here we're just kind of editing a little bit here. Make some kind of cutout if you want. We're gonna remove, this side, whatever.
Mm-hmm.
Let's see. And in a second, let's see. Okay, they're going to do the other side.
Nice.
So I already put some beams in here for,
Mhm.
I guess, balusters, I guess is the term.
We call them pickets.
Okay.
But yeah, the term is balusters.
Okay. And coming up here, hopefully it's soon.
So is that a helix or a spline for your handrail?
Helix.
Okay.
Helix, I believe. Let's see, where is it? Let's see. It's what we call a spiral.
Okay.
No, it could be converted into a
Freeform
freeform line. I guess it's kind of like a spline.
Yeah.
Some commands it has to be a spline, and some commands you can leave it as a helix, because the helix, the benefit from the helix is that I can come right back here and make adjustments to the helix.
Modify the parameters, right?
Yeah, but once I convert this here into freeform or whatever you want to call it, then this this editing capability goes away.
Yeah.
So what I'm going to do here is I made a selection of this, the tread, and the pieces there, and I'm going to say, give it an axis. Here it's going the wrong way, so I'm going to change the arrow direction.
Very nice. So it just did an array of that. Like a polar array along an axis. Is that a yawn, Marco?
Yeah.
And then next here we do a kind of sweep. We skip ahead a little bit.
Yeah,
So
for that handrail.
sweep button in 3D.
So you're okay. I got you.
Select your guideline. Select your cross section. And you can say position automatically. No, I'd like it to stay the way I made it. And then it'll, you know, do that.
Yeah, that's nice.
But this right here is nothing special than what you already have. You're just using the tools that you already have to create this.
Mhm.
Let's see, what else do we have here? Making some drawings. Deriving the part drawings automatically here. Like automatic here, automatic. Here you can flatten that, you can develop a surface. Here's where I'm a little, the guys that do this kind of thing, the companies know this well, but like, how do you actually produce that? I
Oh,
don't
the
know.
helix?
Like how to build that.
We calculate how, it doesn't matter. It doesn't really matter. We factor how many, or it's called a rise in 360. So, and that's going to give you your taper, your rate or your pitch. And that's our standard. That's how we determine most everything when it comes to those handrails is we'll have a certain rise. And then how many times does that handrail go around in that distance? And then we factor angles coming off the center of the center pole that way. Does that make sense?
I think so.
Yeah, and so that way, that that helps us. It helps us when we go to produce the part, roll it through the machine. We could set the machine to certain numbers and get
Right.
it really close because it's materials not all they're not always the same coming out of the mill. They're going to bend it a little bit different, but we'll get it close, and because it's aluminum, we can manually manipulate it pretty easy. I think that looks phenomenal. I think you did a great job. It looks very good. I know it
Don't ask me to
took a
do it
lot
right now.
took a lot longer to make. It's
I was like 8 months ago, maybe I did that. I don't think
yeah.
that's why I have the nice little video, because if somebody wants to see it real quick, because here I have demo start, like here's where I can open this up and here's the file,
Uh-huh.
but I would fumble a little through this since it was about 8 months ago since I
Yeah.
really did it.
Yeah. Yeah, that's why I made that companion app for AutoCAD. It'll produce one in about 10 seconds with all the pickets and everything. Just based on 4 user inputs.
Okay.
Outside diameter, overall height, and center pole diameter, and what else?
My
Huh?
colleague, my colleague took something like that and added parametrics to it. It's not really difficult. You're basically adding variables to your, your copy, your
Algorithm.
spiral
Yep.
copy and stuff like
Yeah.
that.
Once you get the algorithm down, it's pretty easy after that.
Yeah.
Yeah. Anyway, it's about 5 after 1. I've had 3 people knocking on the door so far.
Yeah.
Yeah.
Thanks for sharing that, Robert. I'm gonna save those links and study them.
Sure. And of course, that's something that, we can look at together at a later date if that's something that interests you.
Sure. Probably not for HiCAD though. We've got that covered pretty solid with the software we use for the
Okay.
app. It's tough to beat a entire generation in 10 seconds. And if you ever want to see it, I'd be happy to show you.
Yeah, no, sure, that'd be cool.
Yeah. And I'm sharing with staff here, but not the whole staff knows about it yet. Just couple other people, one other person uses it. So for design, it's solid though. I can't leave it alone. I keep adding little features to it. But and it's all to code too. So it's International Building Code compliant.
Okay.
That was a lot of it too. It'll actually let you build an illegal stair, but it's going to tell you it's illegal. And if it is, it'll tell you. It'll show you the code that it's violating, and it'll even give you every adjustment you need to make. Like for example, increase rotation, or or stuff like that to meet code. It'll take, like for example,
Tread
yeah.
rise or step run or something like
Yep.
that.
Yep. And even same with vertical picket spacing, and when we're doing horizontal pickets, that too. Handrail height. I don't have anything automated regarding it. Just does a generic landing, but maybe I'll get to the custom landing at some point. But I've been working on that thing for 6 months. It's come a long way. It's a pretty solid utility, and you'd like it.
Good. All right. So we said no Friday, right? So we'll do, but the next, I guess next Wednesday and next Friday is okay,
Yep.
at least as of now.
Yep.
Sure.
Okay.
Okay.
Well, in the
And
meantime, if you want to use some of the time on Friday to work on your own, or tomorrow, pretty free tomorrow and Friday if you have questions.
Okay.
Okay.
appreciate it. Yep. Where should we be in the book right now? In your book, page 165, 170.
165. Is that a page number? What do you mean by that?
Yeah. Yeah. Where
Well,
did it leave off in the PDF?
Well, we're kind of around. Here's where, okay, I skipped the cross break, but you can explore that if you wanted to. I was trying to make it look like a HCM panel, but we did explore the Ben Sim. So we're right around here. Now, what we're gonna start doing next is we're gonna skip over here to element installation. And
Are you
here we
showing
got,
the PDF? I can't see your screen.
I stopped sharing. Sorry
Oh.
about that.
That's all right.
So what I was first saying is that we're kind of around 176 here with the sheet metal. I didn't show you the cross break because I don't know of anybody in North America using it, but you can look at that, or we can look at it later. It just creates a dent. It basically
Yeah,
is
it
with
creates
some,
structural integrity, I guess.
yeah.
So we don't need a stiffener so much.
The buttons over here, you see it right here, cross break,
Yeah, we don't have a break for that anyway, so.
okay. So we're maybe just a little bit behind where we could be. But I wouldn't worry so much about that, man. Where's the book I just had pulled up? But if you come over here to, this is where we're gonna start in probably next time.
Element installation training.
Cool. Yeah, this is the good stuff.
And you've already kind of did the first part, and I had this in the back of my mind because I knew what exercise 1 was here. You've already made a basic panel, you just haven't added the parametrics to it. So next time we're going to start into introducing some basic parametrics starting on this page. And you can read ahead if you want. If you want to try this exercise 1 in this book over the next couple days, if you happen to have some time.
Okay.
Basically, you got standard parametric values for length and height. I_L and I_H cannot be changed. This is what it is. So that's those are our system variables for parametric length and parametric